Hello and welcome to the Controller Talk podcast presented by Danfoss North America. Our goal is to bring you information about using Danfoss controls in the supermarket and warehouse industry, specifically in the US and Canada. We're doing these twice a month for now. You can catch these podcasts on Spotify, Google, and Apple Podcasts, and it's also available through the Danfoss Ref Tools app. For the video version, check us out on the Danfoss North America YouTube page. Search for Controller Talk to see our video collection. I'm Dave Yoder, along with Chris Brown. Well, Chris, we're back in the studio, getting back to our roots and talking about controllers. I can see you must be excited.
Eyes are wide open.
Okay, I'm glad to hear that. All right, so this is probably a good time to look at one of our most widely used case controllers when it comes to superheat control, along with defrost, evap fans, lights, and anti-sweat control, the AKCC 550A, or as we'll call it today, the 550A. In a few minutes, we'll also talk about similar controllers, the 550 and the 525. So the purpose of the 550A is to handle all the case functions for one evaporator. Other controllers we have can handle as many as 4 evaporators, but this one controls one evaporator. The controller can operate as a standalone controller, but in most applications it will be networked to a front-end controller like a 255, 355, 800, or 800A. This allows history info to be saved, alarms to be transferred, and the use of schedules. Schedules in the front-end controller are used to send defrost start commands and turn case lights on and off for many controllers at one time. And there are 2 varieties of this controller, 115 volt powered and 208 230 volt powered, and each one of them has its own part number.
Yep, that's right. And as far as the 550, the I/O on it, the inputs and outputs, it's not something like our AK2 modules where you're looking to expand it. Maybe build it to what you really need. Everything's right there when you have the case controller out of the box. So the sensor side of it, you're going to have that same format that you have on other controllers we've talked about in the past. So a little bit of what the 210 had, for example, with the naming convention. So we start off with the S2 sensor, which is what gives us our coil outlet temperature reading that we'll need for part of that superheat calculation. And then the S3 sensor, which is typically associated with being in the return airstream of the case or walk-in. We don't need that one. In most situations, it's optional. But if you're getting into a few unique situations, then it is something you're going to want to add in. So adaptive defrost is something that a lot of people see as a benefit in the 550A. If you're going to use that function, then you need to add the S3 sensor in there. Walk-ins, a lot of times people like to return off the return or control based on the return rather than the discharge. And if we're going by the letter of the law, then you would want to wire that to the S3 to get it to control for that.
Right.
S4 is our common one that you see all over the place. That's our discharge air, which is typically used for control, especially on reach-ins and some of your standard display cases. It's also your default that's going to be used for the alarming, and it's something maybe more so medium temp than low temp, but it's also something that you can use or set up for defrost termination. S5 is the next one on there. That's your defrost termination sensor. That can be a dedicated sensor separate from what's being used for your temperature control. So again, if we're looking more at a electric defrost, low temp situation where you typically have something right on the coil, then the S5 sensor is where you're going to land those wires on the case controller to read that. And then it can also be used to restart your evap fans on temperature after defrost as part of that logic there as well. S6 we don't see used a lot. You're going to see that on the case controller. If somebody wanted to monitor product temperature, HACCP reporting, something that Danfoss gets into some. But if somebody wanted to monitor or had some unique situation, maybe it's outside of the product sensor, but a second monitoring point, then S6 can be used for that. And then last but not least, from an analog sensor side, your pressure transducer. So we refer to that as PE. That's used in conjunction with the S2 temp sensor, which is on the outlet of the coil. And those two together give us our superheat value. And that's one of the things that we're going to use to determine how far to open or close the expansion valve. Then you kind of switch gears to the digital side. There's 3 digital inputs that we're going to have on the 550A. 2 of them are just dry contacts, DI1 and DI2. When you get into the programming of the controller, you can set up what they're actually used for. We're talking about things like a door switch, dual temp modes. You can switch between that. If you wanted to start a defrost on a DI, then you can do that as well. And then you've got DI3, which is a wet voltage or a voltage driven digital input. So it's not just dry contact. We've got to have line voltage on there. It can be set up for the same purposes as far as the functions of it with dual temp, door switches and whatnot. But that's the third option you have on the 550A.
Yep. Okay, and then if we start talking about relays, we have 2 different types of relays on the controller. You have a solid state relay for the AKV electronic expansion valve. This one's limited to 0.5 amp, and that can be important to know that. But it is designed for millions of cycles, and that's why it's a solid state relay. There are a total of 5 of your standard relays on the controller. 2 of those are Form A, meaning they have just normally open contacts. And then you have 3 that are Form C, where you have a common, normally open, and normally closed contacts. Now, the function of the relays is determined by choosing from options in a parameter on the controller. That's parameter 061. And some of the relay choices that we have are for compressor, defrost, fan, anti-sweat heater, alarm, and lights. Now, option 2 in parameter 061 gives you an anti-sweat relay, no alarm relay, and this tends to fit pretty well with most applications. Also, none of the relays are fused on the case controller, so that's good to know. And regarding relays, the last thing is that if you have ECM evap fan motors, which are fairly popular these days, they can kill an evap fan relay pretty quickly because of the high inrush current. So typically you'll see the 550A combined with a case power module board or pilot relays to handle that.
And I think the other thing to keep in mind with the relays is just that they are dry contact. Sometimes I think people expect on the AKV in particular that it's kicking out a voltage for the valves, but you still have to feed that voltage of the coil that you're using on the valve through one side of that relay as well.
Right. We're just making and breaking a signal through that.
Yep, exactly.
Okay.
So once you've got it wired up, then the next steps obviously to get into the programming to set the thing up, which you're going to see there's a couple ways to do that. Just like we had with the sensor naming conventions, the parameters for the setups very similar with other case controllers as well. The 210's one that you could kind of compare from that standpoint if you wanted to. So all your parameters are kind of grouped by category, where we get just a letter to kind of indicate what the function is tied to. So something like R, all your R parameters are going to be your basics, your set points, and that sort of thing. C would be anything tied to compressor control if we're controlling a compressor relay on the case controller. D for defrosts, F for fans. We have N, which do you know why we picked the letter N for Superheat?
I guess S was taken.
Yeah. So, but yeah, just keep in mind that anything that starts with N is kind of tied to the injection control. Maybe they went with the last letter instead of the first there.
Right.
But yeah, things tied to the superheat control of the valve. A for alarming, and then they went with the mysterious letter O for miscellaneous for all the other odds and ends that we're controlling. Rail heat, the DIs, the function there for the DIs and whatnot.
Yep.
They kind of separated out the set point for the case controller. I think the idea there was that it would be a little easier to get to than diving in through all your parameters and scrolling. So if you want to just change your set point and make an adjustment there, when you're at the case controller, there's 3 buttons on the right side. You press that middle button and that gets you right into the set point for the case. We have and something else you're going to see across all these different case controllers is something that we refer to as a main switch. And so it's not a physical switch. It's a kind of a virtual or a programmable switch. That's one of the parameters in the case controller. It's parameter R12, and I think just about anything you'll see except for the 750 that doesn't use those the same menu structure. But the main switch is something that starts out of the box in the off state, and there's some kind of main parameters if we're going to make an adjustment to things like refrigerant type or the application, that we have to make sure it's in that off state to make those changes. Otherwise, if we want normal operation, we change that main switch in the program to an on state to get regulation to occur. And if we don't, then we're going to get an alarm. We're going to get no control out of the valve or any of the other functions, like we said. And it may turn into a call of, hey, this thing's not doing anything. What's going on here? And it's just as simple as changing that switch to an on state.
Right.
Again, programming, so one of the options you have is just setting this all up from the buttons right on the front of the controller. There's 3 buttons just to the right of the display that let you get into the parameters and navigate through them. And probably easier, and a lot of times it's set up this way to take place. The other option is in the system manager that the 550A is probably going to be tied to. If the set points are already set up in there, or if you want to set them up in there, you can just download it from the system manager to the cage controller once it's online with the system manager. It's pretty quick. I mean, you're talking 10, 15, 20 seconds as long as there's no communication issues there.
Yep.
So that's normally the route we see, where it's a program that's been set up ahead of time, and once everything's wired up and online, we just download into each case controller individually. Just again, mentioned it a second ago, but it's worth repeating that when we are, if we're going that route, especially of downloading from the system manager, because you don't always get the feedback to tell you it didn't happen. But if we don't have the main switch in that off position when we download the settings into the cage controller, some things just aren't going to get sent down, and you're going to say, well, I set everything down. I think I'm good to go. Why isn't this working? And if that main switch was on when you downloaded, you're not going to get your refrigerant type in there. And that's obviously something that the cage controller needs to know when it's trying to calculate its superheat. So just keep that in mind, that when you're downloading your settings, you want to make sure that main switch is in the off state. Get your settings in there, and then after that's done, go back and change that main switch back to on as your last state or last step to get everything up and running. And then one other thing to mention is that if we run into a situation where maybe your settings are hosed, you just don't know how this thing's set up, and you think it's just easier to start from scratch as opposed to trying to get to the bottom of a problem, the case controller does allow you to go back to factory defaults, and you can actually define what those factory defaults are. So just hold top and bottom buttons in on the case controller and power cycle it, and that will get it back to those factory settings for you to start from scratch.
Yep. If you did it right, you should see FAC on the screen.
Yep.
Right after it kicks in.
Right.
Yep. All right, so this is probably a good time to remind our listeners about the Cool Code app that can be downloaded to your phone. And of course, in this case, cool is spelled with a K. It has lots of controllers listed in the app, including the 550A. You can look up parameters, status codes, alarm codes, and see parameter options. It's actually pretty handy when you don't want to carry a manual around with you. So let's talk about some of the other things that get overlooked when it comes to setting up and troubleshooting these controllers. If you see the symbols on the left end of the display all flashing together, that means that you have an alarm in the controller. So you'll press the top button for the alarm code, and then of course you could look it up on your Cool Code app if you're not sure what it is. It could be something as simple as the main switch is off, like we talked about, or something more serious like a jacked up transducer reading, which could throw off the calculated superheat. The symbols on the left end are a snowflake for cooling, a melting snowflake for defrost, an X to show that the fan relay is on, and if we look at some other parameters, there's some important ones to know about. So parameter D01 is the defrost type. One option is to select off, which you might assume is off time, but don't be fooled by that. It actually means no defrost. So if you get used to selecting electric defrost for all cases, then you won't have to wonder why the case never seems to defrost. So just pick electric instead of off and you should be good. So sometimes I'll ask a caller to press the top button to give me the status code, and they tell me it looks like 523, but it's really S23. S, of course, is for status in this case. And if you look it up on your app, it's described as adaptive superheat. And then that means that the controller is trying to achieve the superheat target known as max superheat. And if it can achieve this superheat number, it will change the superheat target to a slightly lower number and keep doing this until it gets down to the minimum superheat number. So that's an ongoing thing while it's in refrigeration. It's been our experience that these controllers are reliable as long as you keep them dry. A wet 550A will not be reliable for long. That just seems to be the way it works. If you have a case running warm, one of the first things to check is the superheat reading, which can be viewed on parameter U21. A superheat reading that is too low will keep the valve from feeding or make it throttle back to the point where you're just not keeping the case down to temperature.
Yeah, it's probably one of the most common calls we get. Just
right.
Temperature in the case is warm. Why isn't my valve open?
That's right.
So, yeah. And then if we switch gears to communication, as far as the case controller being able to report back into a system manager, you've got some options there. And so Modbus is one option. It's the most common one today. I don't think it was the most common when we started. Most everything we did was Echelon, but we've learned over time with the 550s in particular that it's just as robust and it works just as well. Mm-hmm. So Modbus is one of the options you got on the case controller there. And then the other option is LAN 485. The difference between the two is that the LAN 485, there's an extra accessory you've got to add. So just below the display, there's a small plastic cover, which I swear is spring-loaded sometimes. I've shot that thing across the room more than once.
Right.
And I've also been to stores where I see them not there anymore, and I can venture a guess as to why.
They're missing.
Yep. But if we're using the LAN 485, and this is something that should be determined ahead of time, if this is a new store we're talking about, whether we're going Modbus or Echelon. But if it's Echelon, then the cards need to be there. If you're replacing one in the field, the card needs to be either installed or moved over from the other one if it's a situation where we know the card is intact and okay.
Right.
But that slides into a little slot just below that cover behind that, where the display is, just below that, and then you can slap the cover back on top of it and you're good to go. As far as the plugs on top, you need to pay attention to that too, because it's not just a matter of having the card in there and the controller knows which communication type you want. If you look at the top right corner kind of the case controller, the far right would be where your Modbus connection is, and then just to the left of that, if we're using Echelon, there's a separate plug that you need to wire into instead. So just something to keep in mind there is know what communication type you're wired into and go to the appropriate plug at the case controller. And then as far as differentiating between the case controllers in the store, we've got to make sure each one has its own unique address, of course, right?
Right. Yep.
So with parameter 003, you'll get to know that one very well. That's your parameter that you go into if you want to address the case controller. And there are some things, again, typically in a new store or in a replacement situation that are going to have to be done down at the case. And this is one of those things. We need to make sure that the case controller has the right address in it so the system manager knows what it's talking to. So once that address is in there, you then return back into the system manager, and that's where you can do your rescan to tell it to go out and look for that case controller to pick it up. Once the rescan's done, and assuming everything's successful, it pulls in some information for you. And so again, whether this is a situation where you've already programmed the case controller into the front end and now you're just bringing it online, or maybe it's somebody that's just bringing it online and then they're going to program it afterwards, there's different parts of the program you might need to use for some information. So in that rescan screen, there's some other sections that are going to tell you whether or not it found that case controller or that address. It's going to give you what part number the controller is, because that plays into later on when it's selected in the program. One of the things you need to pay attention to on your type is the part number. The application type it'll confirm for you. So what we're using those relays for, the 550 typically has about 10 different options for your applications. So the rescan screen verifies what that is, because that also plays into your selection type. And then it can give you the software version, which isn't something that's always all that visible. And that's something else that plays a big role in what we're setting up, because if you don't choose in your drop-down list the right software version for that case controller, you're going to start to get some errors and not get the proper status screens that you expect. So outside of that, some other general things that we just haven't covered yet, but they're good to keep in mind as well, is that the controller, when we program in that set point, that's not kind of your middle point, and then you've got a plus and a minus or a differential. Your set point is your cutout. And so when we hit that cutout, that's when we're going to stop our refrigeration. But then there's also a differential parameter in the program, R01. And the way the case controller's logic works is that it adds that differential to the cutout to create your cut in. So if I've got a 30-degree cutout, but I didn't pay any attention to my cut in, or my differential rather, it could be 3, 4, 5, 10 degrees, whatever somebody might have set it to.
Yep.
So just keep in mind that there's your main set point, but there's also that differential that plays into when the expansion valve is going to start to refrigerate as far as a cut in and cut out.
Right.
When the refrigeration does turn back on, once it rises above that cut-in point, the case controller normally starts in a mode where it's just worried about what the superheat in the case is. We do have some different modes, some modulating it's called, where we can worry about case temperature and kind of prioritize that over superheat to some degree. But normally when we're in that startup mode, afterwards, we want to make sure we're in a proper superheat range. And then safety side for the case controller, I mean, again, we want to prioritize superheat, especially when we're in some extreme situations. We obviously don't want to see any flood back. So if the superheat drops too low, we do have a absolute fail safe. We call it superheat close setting. And if we get below that, we're going to shut that valve off immediately. Normally, it's not a situation we're going to get into if it's a normal running system. Usually, we're either using our adaptive superheat mode where it's already started to throttle down the valve and close it off some because it knows the superheat was dropping. Or even if we're in this modulating mode where we do have a little bit of a higher priority on case temp, then we've got some logic tied to that as well that should hopefully start to close that valve down before we'd ever get into that point of having flood back at the compressor level.
Yep. Okay, so when it comes to defrost, normally the front-end controller tells the defrost when to start. After it starts, the case controller takes over from there. There is no minimum defrost time, and there is no digital termination. You can terminate on time, discharge temp, or that defrost sensor on the coil we talked about, the S5 sensor. So the question is, what happens if the case controller does not receive the command from the front-end controller to start a defrost? So it could be due to a schedule being disabled in the front-end controller. It could be that a floor saw cut through the comm wire that night. Could even be Mickey Mouse getting his copper fix overnight. And now you've got no connection to the case controller. So the D03 parameter in the case controller acts like a backup defrost option. And it's based on elapsed time since the last defrost. So let's say that you defrost every 8 hours. You'll set parameter D03 for 9 hours. If the case controller realizes it's been 9 hours since its last defrost, it'll start its own defrost. And that's important to make that distinction, because if you would set D03 to a number that's too small, then you can have defrost kind of stepping on each other.
Yep. And
you'll get more than you really want. All right, so let's briefly mention some similar controllers that have been installed out there. So the AKCC 550 was released before the 550A, and it's very similar, but one main difference is that there's an option in that controller to control based on delta T across the coil instead of superheat. So rather than a pressure transducer, you had an S1 temp sensor on the inlet of the coil. And because placement of that sensor was critical, most people opted for using the transducer instead, and that option was actually removed in the 550A.
Yep, that's right. And then one of the other ones that's in a very similar situation is the 525. And so, again, if you know the logic of the 550 or 550A, the 525 is going to operate pretty much exactly the same. What happened with the 525 or the backstory on it is that we saw a need in the market to prioritize cost over the full functionality of the 550. And most electronics, the display is the big cost in the design of it. And so the market said, give us something that has a lower cost to it, and we understand that the cutting out the display is going to be part of that. But we have remote displays and things like that that can be hooked up. It's typically going to be on the system manager, where most of the time that's where somebody's looking at it anyway. So that's when the 525 was introduced into the market, was to fit that need. So again, no display built right into it, no buttons on the front of it. We had a few small features that were removed just because at the time we were building it, we knew where it was going to be used most of the time. So adaptive defrosting is one of the things that you're going to see stripped out of there, and then the dual temp options was the other one. So again, we primarily were expecting it to be used on medium temp cases. So that's where we said we can strip those few things out of there and we'll be okay.
Yep.
If you're programming in those initial things that you need to do to get it online with the system manager, so we're talking about the address and the application again, there is a display that you would have to plug into the 525 to do that. And it's specifically the 164B with the Molex plug on there that you have to connect, not the 164A that you can wire up with individual terminals. So I mean, just people kind of being caught off guard with not knowing that they needed to have that display and worrying about getting a hold of it, and then how long that would take, and then being stuck in no man's land. I'd say the 525 is out there some, but it's by no means as popular as the 550A is in these stores.
Yep.
So,
Yep, it's true. All right, so in part 2 of our talk about the 550A, we'll cover the interface with the various front-end controllers and how we use files to make it all come together. So stay tuned for that. All right, Chris, it's time for your favorite part of the episode. And that's the Stump Crisp part, where I'll throw some questions at you and see what you know. So I need you to confirm that I have not shared the question nor the answer with you.
Nope. This isn't going to be a gator question, is it?
No alligator questions this time around.
That's good.
So, this is a multi-part question, but I think it's going to be like teeing up a softball for you anyway. So we'll see how you do here. You might go 3 for 3.
Yeah.
All right, so how many different types of transducers can be wired to the 550A to read the evap pressure?
Oh, I mean, it's got to be ratiometric.
Well, that's very good. Okay.
So,
Yep.
I mean, we've got our 32R,
Mm-hmm.
which is the 174 PSI range. We've got the CO2 sensors, which goes up to 855.
Mm-hmm.
We talking model type, part number? What are we talking here?
Let's just say part number.
Part number? Oh,
Yeah.
goodness gracious. I can think of at least 5 different types off the top of my head.
Okay, but if you hook up a ratiometric transducer to
Yeah.
the controller, you're good.
Yep.
And the actual controller allows you to program in the pressure range,
Right.
so you're good there.
Yep.
Normally we go from negative 14.5 psi up to 174 for the HFC stuff.
Yep.
And then we of course have a much wider range for the
CO2
CO2.
side.
Yep. All right, you're doing good so far.
That was a very vague answer, but I'm saying I got it right.
We'll let the final judges decide that. So what is the voltage range of the transducers? Because I would say they're all the same.
They are all the same. So we're feeding it 5 volts to
Okay.
it. And so as far as the supply voltage coming back, it would be half a volt to 4.5 volts DC.
Right. 0.5 to 4.5. Yep. Okay, you got 100 on that one.
Killing it like the Orioles.
Yeah. When you said ratiometric, I knew you were on the right track. All right, so let's move on to listener mail then. And this isn't exactly mail per se, but it's a story. So as you know, Chris, the world is a smaller place, and we get emails into the box that are spam. You know, I got a few for part numbers and things like that, and that's cool.
Yep.
And there's always a couple surprises in there. So recently I got an email from what I call the Hickory Farms of Vietnam.
Okay.
And it was all in Vietnamese. So, of course, I ran it through Google Translate.
Sure.
And apparently that's the place to get mooncakes, just so you know. And I'll need your credit card in a few minutes because I have an order to place. So moving right along from listener mail, if you'd like to drop us an email With a suggestion for topics to cover, a question, a comment, you can email us at controllertalknorthamerica@danfoss.com. Thanks for listening. Our studio and video engineers are Michael, don't call me Mike, Beckerman, and Jordan, the man Larson. Our audio engineer is that international man of mystery himself, Raul Garcia. And our Romanian rotational global intern who gets no credit for all her work is Maria. I think she must be in the south of France on holiday or something, but I haven't seen her for a while. Until next time, for Chris Brown, I'm Dave Yoder. Stay cool.